Okay, question number 4. A particle moves in a straight line such that its velocity v meter per second at time t seconds is given by this function. Domain t is restricted from 0 to 2. Find the velocity of the particle at t equal 2. And find the maximum velocity of the particle, and then C is find the acceleration of the particle at the instant it changes directions. To analyze this function, we need to draw this function using our calculator. See, let's see y2. So function vt equals 1 plus e to the negative x, and then minus e to the negative sine of 2x, this function. And then domain is restricted from x test greater than 0. Second test to go to logic n. X second test go to test and smaller than 2. So we can draw this function here. Yeah, so from 1 to 2, let me see. Let me confirm 1 plus x negative t minus e to the negative sine 2t. Okay, so this function here. So A, find the maximum velocity of the particle at t equal 2. So when t equal 2, delete it, when x equal 2, velocity means v of 2 equals negative 0.996. 0.996. The unit is meter square per square second. Meter per square second. Find the maximum velocity of the particle. So maximum velocity happens when here, right? So it's gonna be x equal, so GDC, so t equal, maximum velocity. So when t equal 0.388, maximum velocity y equals 1.182, so 1.18. So we can see that this is maximum Vmax equals 1.18 meter per second. Question number C. Find the acceleration of particle at the instant it changes direction. When it changes direction, it means that when v equals 0. So we need to find acceleration of particle when v equals 0. V equals 0 when this function here. So v equals 0. So v becomes 0 at time t equals 1.66, right? We need to find acceleration of this one at 1.66. So simply using GDC, we can find the function of acceleration. So y3 we can define, go to math, go to derivative of function y2 with respect to x. So this is derivative function. We need to find the acceleration when t equal 1.66. So a of 1.66 equals, go to purple function. So go to calculate, go to purple function when x becomes deleted on 1.66. So it will give us negative 2.54. A little error in it because let me see. So when v is 0, so here so this number here is not equal, actually equals 1.65841. we cannot use the three significant figure until the final value. So this value here, so it can be used. So this value entered over here, 1.65841. We need to find acceleration of this one. So go to calculate, delete everything, and then put the 1.65841, and it will give you actual answer. This can be written to minus 2.534, but three significant figures. Because this is final answer, we can put this one number here, minus 2.53 meter per square second, because this is acceleration meter per second square.